Welcome, and thank you for joining us for this IHEAM webinar. My name is Victoria Emerton, and I'm the Conference Director for Healthcare Estates. This webinar will be presented by Lee Priest, Sales Director at Power Electrics Generators Limited. The presentation is called Impact on the Healthcare Sector of the Medium Combustion Plant Directive. Please visit healthcareestates.com for on-demand webinars and information on IHEAM Digital Week, which will run from the 5th to the 9th of October. I'd like to hand over now to Lee. Thank you.
Thank you, Victoria, for that introduction. As Victoria said, my name is Lee Priest from Power Electrics. About a couple of years ago, I gave a presentation on the Medium Combustion Plant Directive at the IHEAM event. This today is a refresh on that, but firstly, just a brief introduction of who we are. Power Electrics started looking at Medium Combustion Plant Directive around about 3 to 4 years ago, when we realized they would have a big effect on our business with regards to the fleet we have, which is in excess of 1,600 hire generators, as well as our customer sites and servicing, and etc. as well. So really today it's about tearing this towards the healthcare sector for you guys, but also giving you some experience we've had from other areas as well, and hopefully for you guys to learn something and then be able to explore further if you need to do any actions off the back of this. Now we move on to the explanation of what is the Medium Combustion Plant Directive. Back in November 2015, the European Parliament signed the directive really for the Medium Combustion Plant Directive, and this really aims to reduce the amount of sulfur, oxides of nitrogen, and particulate matter or dust in the atmosphere as well. This is for equipment between 1 megawatt thermal and 50 megawatt thermal. Doesn't include the larger stuff, which is associated with power stations. But yeah, so it came back in 2015, and you'll see timescales later on in the presentation of how the UK have adopted this and where we are at this current point now. So one of the reasons for the UK adopting this, well, some of the reasons for it, and this is some information which was given at the DEFRA consultation. So really, nitrogen dioxide, NOx, and particulate matter contributes to around about 50,000 premature deaths per year, and an estimated cost of £30 billion per year to the UK economy. I think this data is not for off-road, which is what this includes, so medium combustion off-road. I think this also allows for transport as well. That's something which won't be tackled today, obviously. That's something completely different. So starting from the beginning then, what is a medium combustion plant? As I already indicated, a medium combustion plant is any piece of equipment that burns fuel, and that can be gas or can be normal diesel, petrol, any sort of fuel, which sits between 1 megawatt and 50 megawatt thermal. Now, depending on the efficiency of that piece of equipment, that effectively equates to 400 kilowatts to 20 megawatts of an electrical load. And also, this only looks after medium combustion plants which produce heat and electricity, or just electricity on its own. Anything outside of that is covered by completely different legislation. And today, really, this presentation will move on shortly to more talk about generators. But there are the legislation for CHPs and so on as well, which need to be talked about as well. So first of all, in the UK, within the UK, unfortunately, it's fairly divided in the way this regulation has been put into place. So in England and Wales, the DEFRA and with the EA adopted a specified generator regulation. So specified generators, Schedule 25B, Statute Instrument 110, basically, is the regulation of medium combustion plants from 1 megawatts to 50 megawatts thermal. Also, what's probably not known so much is people participating in demand-side response, and the capacity market actually takes it down to zero as well. So this is one thing which is hidden within that specified generator regulation as well, which not a lot of people realize. It also encompasses individual generators and multiple generators. But there is a guidance document available on EA, and this was published in September 2018. That was a little bit later than it should have been published because the legislation came in 2019. but that's readily available now on the Environmental Agency website for people to have a look at and digest and understand. So going on to generator controls a little bit more. First of all, they decided to, because it looks after existing and new equipment, then tranche A is classed as existing and tranche B is classed as new. So there are some transitional rights which were available for some of the people participating in the capacity market, demand side response, those kind of areas, but that goes back to 2016, 14 and 15, depending where you are, even below 1 megawatt thermal as well, so below 400 kilowatts electrical. Then you have, there are some you have to meet those criteria. So effectively, if you have a capacity market site or you're being running a demand side response contract for before, I would say 2016, then you may be okay. But the legislation has changed slightly, that actually it is the responsibility of the operator with the aggregator now to make sure everything is abated. So effectively everything becomes what's known as tranche B. So anything from 2019 onwards needs to comply with the Medium Combustion Plant Directive. I suppose there is some good news. There are some exemptions for the Medium Combustion Plant Directive or any medium combustion. So if you have a generator or a piece of equipment which has a nuclear safety role, this doesn't include the instruction or the construction side. The construction of these, it mainly means, i.e. the operation of the nuclear site. Anything which falls in the Industrial Emissions Directive, so effectively anything above 50 megawatts thermal, then you're almost treated as a power station. Probably want to try and avoid this because it has clauses in there like continuous monitoring and other bits as well. Any offshore oil and gas storage uploaded platforms will be exempt from it. Also, anything which is captured by the Non-Road Mobile Machinery Directive, NRMM directive. Sometimes this is known as NRMM London, but it's actually it's the tier staging of modern engines. And this is a completely different directive, which is actually more stringent than Medium Combustion Plant Directive, because this only looks at NOx and doesn't look at everything else. But probably the best news for anybody working in a hospital or working in the NHS is that if you are using the generator purely for backup purposes, for up to 50 hours a year testing, and then unlimited if you hit an emergency, if you lose your supply, then basically you're exempt from this legislation. The best way to put it is if you're not using the generator for commercial gain and it's performing a life safety function, then you don't need to worry about this standard. You may have to log the hours and log the fuel, which we'll come to later on about permitting. However, if you're going to run over 50 hours testing per annum, then what I would say is talk to the local EA people and tell them and explain the reasons why it may be some operational requirement of the site or the hospital where you actually work at. Just to touch a little bit on mobile generators, this was really implemented within the standard because, well, effectively, you didn't want people with static generators making them mobile and being exempt from it. So, but it had some consequence for people like DNOs, so the electricity companies, water companies as well. So effectively any maintenance activities by a general building, so transformer replacement, switchgear replacement, electricity, DNO, tree cutting, other things as well, water utility maintenance, is exempt from the Medium Combustion Plant Directive. However, it's only exempt for 6 months. After 6 months, you need to have a discussion with your local environmental agency and explain the scope of what happens as well. A lot of the consideration within this is to try and free construction site from existing main supplies as well. Additionally, I've already touched on NRMM, but this is coming into play at the moment in 2021 and 2022. So particularly in the London emission zones, HS2, other areas as well are starting to adopt what they call stage 5 engines. So if you've got mobile generators turning up on site for work, you may end up with stage 5 engines coming on site and so on. But it's a different subject to today. And unfortunately, they don't seem to work together with the legislation, although hopefully maybe in the future they will do that. So just to take you back a little bit and talk a little bit about McBD timelines. As I said originally, 25th of November 2015, the European Union signed this legislation. From May 2016 to 2017, a consultation process took place within industry on this. Workshops where we first got involved really in August 2017 was given out to about 1,000 different organizations and companies. The legislation then came into force in January 2018. Unfortunately, the legislation came in force and the guidance didn't come in until September 2018, which on the next slide, you'll see why the effect of that is. So by the 28th of February 2019, people had to apply by this. So possibly only gave 3 to 4 months for people to actually get their head around what they needed to do for this. So there's been a bit of a delay in people of abatement and doing things, which I'll talk to you later about in this as well. So just to run through this briefly, there is an intermediate one back in October 2019 for a set level of 500 milligrams between 5 and 50 megawatts thermal. But effectively, anybody who has who operates a site above 5 megawatts thermal will need to comply by 2024, 2025. Anybody below 5 megawatts thermal, so that's 2 megawatts electrical, will need to comply by 2029, 2030. So yeah, okay, you have 10 years if you sit within that 2 megawatts and below, but I would imagine most NHS sites will sit above 2 megawatts with the capacity they have on site if you participated in commercial gain. So let's talk about the levels a little bit. And these two slides are from the legislation. So the thing to take from this is that the level for gas oil for diesel is 190, which is milligrams per natrified meters cubed, and 95 then for natural gas. So the new, that's for any equipment new after 2019 will need to comply with this if participating in commercial gain, i.e. DSR or something else. CHPs is commercial gain as well. If you substitute it for electricity, it will be classed in this as well. And the biggest part of this as well is for both gas and diesel applications for generators, CHPs, then 190 will need to be met across the board. So doesn't matter how old the equipment is, it needs to meet that 190 as part of this specification. So just a slide really to probably shed a bit more light on it. So the best way to look at this, if you look at the left-hand side of the presentation first and just focus on the diesel engines. So for new and existing, I said 190 milligrams is what you have to meet. So the standard is derived at 15% oxygen, but most OEMs will go between 5 to 7% when they give you the NOx levels of their engines. So you need to extrapolate that to 15%. So a diesel engine at 15%, fairly modern one, will be running between 600 and 900 milligrams. Now to get down to a level of 190, you can see that there's a fair level of abatement involved in that. So really you're going to have no other option than to use an SCR device for that with an AdBlue dosing system as well, which I'll discuss later on as well. With regards to gas engines, the NOx levels are lower. So, and as I said before, this only focuses on NOx from the medium combustion plant directive. So therefore, for new, it needs to be at 95, and for existing, it needs to be at 190. Again, looking at the 15%, then a gas engine will run between 180 to 215 at fuel optimized, and then at emissions optimized, it can run between 85 and 102. So in theory, it's possible to meet this legislation without abatement on gas engines, but effectively you will burn more fuel. As one of the things you'll find with engines is that you will have, that effectively you burn more fuel to make the emissions lower. So you'll either have fuel optimized engines or emissions optimized engines. So the more fuel you burn, the lower the NOx levels. But in some gas systems, you're looking at putting SCR systems in with AdBlue or just catalyst systems. We have a couple of the range of gas engines we look at which have a level down at 50, but they do have a three-way catalyst in them to achieve this as well. So just a little bit of an idea on these mitigative measures, on these, what it equates and how much is it going to cost you, what's the impact for everybody here. So as I said, so if you want to get, so by putting an SCR system on, you can drop that down to 60 to 110 milligrams, up to a 95% reduction. Similar to gas, you can get it down to well below 50 by using SCRs and using these mitigating measures, but that comes at a cost. So the CapEx approximate cost is around about £60,000 a megawatt for retrofit and also for new. New is obviously easier to retrofit something in a plant room or onto a container, has its issues and its problems with that as well, but can be overcome, no problem. The operational side of it for diesel, again, is around about £3 per megawatt hour. Most of that actually comes from the operational cost, from the AdBlue and maintenance, although the maintenance on these systems is not great, actually, it's not a lot. With regards to gas systems, then it's a little bit more expensive because the SCRs tend to be a little bit bigger, so you're probably looking at around £75,000 a megawatt and about £4 a megawatt hour operation because you're burning a little bit more AdBlue and that's one of the consequences of it as well. So just specifically to talk about the NHS today, and just really take this slide away and just think about the applications or the sites you're looking at as well. So all applications within the NHS are life safety. They're there to back your critical wards and everything there as well. Most hospitals tend to have a hell of a lot of generators on there, varying ages, varying types, varying specifications. You'll see there's quite a lot as well. But just for its prime use of emergency for life safety, it's absolutely fine within MCPD. You will have to cover and permit this generator at some point and log its hours and its use and the fuel it's used, but we'll talk about that a little bit more afterwards. But actually for maintenance work and running in the absence of mains for an emergency, you'll be absolutely fine. But as I said earlier, just be very, very careful that when you go over to 50 hours and you go over the 50-hour testing, just report that to the EA and then make sure it's documented as well. Where the sea change will come in and where things need to be abated and need to be looked at is that if you're doing triad avoidance, there was some debate whether triads are involved and are captured by this legislation, but actually it is, and on that generator guidance document, it's very, very clear that triads are captured. I think there's only a couple of years left of triads now, but whatever system comes in to replace that will come under this and will be part of the MCPD as well. Now, if you're looking at store, demand side response, capacity market, fast frequency, whatever you participate in with an aggregator, then actually you'll need to comply with this and you'll need to comply with this legislation. So probably the best advice for this is if you're applying and talking to an aggregator, start opening conversations with them about what their take is on it and what they want to put you into the marketplace if you haven't done that already. Also, more than happy to come and talk to us about it. We can chat to you about it as well. And just one final thing, it touched on it with a mobile plant earlier on. Just be very careful when you go works on sites, if you're doing maintenance works or maintenance or transformer replacements or capital replacement projects, that if you have temporary generation on site, probably prime running and not standby, that you will fall into scope of the MCPD. So again, that's going to be a local discussion with the EA as well. So just a little bit of a conversation about installing SCR systems. This is the generic type of FG Wilson generator system on a skid and open unit. But what it's really illustrating is that it's around about 40% efficient, the engine is, with electricity. So you lose roughly 60% through the radiator and exhaust combination as well. Now, bearing in mind the SCR is going to be fitted on this exhaust. So some of the heat coming out of our exhaust is in excess of 400 to 500 degrees, which is fine because you need that for the catalyst to work as well. But so for every kilowatt of power you produce, you generate 2 kilowatts of heat as a rough rule of thumb. So on a different conversation, you need to be able to allow for that heat whenever you install generators into any installation, basically. So when you install an SCR system is a catalyst system, precious metal catalyst system. You can see some diagrams on here, or see where they are sat on one unit. So it's a box, it comes off the exhaust systems. You want to locate it fairly close to the exit point of the exhaust. And one of the reasons for this, or the main reason for this, is that the system runs between around about 200 to 400 degrees centigrade, or 250 to 450, depending on the ranges and how the catalyst is set up. Anything above that, then the AdBlue probably vaporizes a lot quicker, and therefore doesn't cause the catalyst effect you want. Below that, then it doesn't vaporize and it doesn't burn properly. So therefore, you have to get it spot on and have to get it as close to the end point of the engine as possible. So within probably a couple of feet of the end of the exhaust. So for instance, you couldn't have an installation where you put it at the top of a chimney or something like that, or top of a stack. So one of the things to be careful with this, and I think this is where people will fall over, is be very careful, because the more bends you add into this system by putting this catalyst on it, although it's a fairly free-flowing device, you can actually cause more back pressure for the engine, and one of the results of that is a turbo, and that photograph is actually a turbo glowing red hot, because there's not enough airflow coming out of the engine to take the exhaust away. So you have to look for this. So back pressure is critical when putting these systems in, not to cause any effects as well. One of the other things to look at as well is noise. If you have a specific noise requirement for a site, you're effectively taking away a silencer. And although an SCR system will reduce the level of noise and take that level of noise down, what you will find with it is that it isn't as good as a silencer, but you have options of putting these SCR systems within silencers. After the silencer, there's a couple of case studies in a minute which will show you how they look when they're on larger generators. But yeah, you can put them however you want, but particularly in a plant room, if you have an application where above the generators there's not a lot of room, it can be quite difficult to fit the SCR systems in as well. And this is where the experience comes in, and also with that prime thing as well, as not to reduce the integrity of the existing system and to maintain it. Obviously on the new system it can be designed in and put in from the start, which is great, and it's a lot easier to be there. So the three systems involved, you can basically abate up to 95% from 65%. You can see when we went through that slide earlier on, that you're looking at reductions of around about 70 to 80% to get anywhere near the legislation, depending on the level of engine you have and where you are with it. But anything above 95%, you will struggle, because you probably burn more AdBlue and you will not get it towards 100%. So 95% is probably the maximum you will do. And one of the risks you'll come across then is what they call ammonia slip. So obviously AdBlue contains ammonia, and it's a form of ammonia. So therefore it's a safer form of ammonia than it being neat. So what you don't want is ammonia being discharged into the atmosphere. So that's one of the things to consider with it. And so don't try and push them too far. 90 to 95% or 80 to 90% operation is fairly within its limits, and you're going to reduce the amount of ammonia slip. Although these systems are closed loop, so it does monitor this, it is quite good to be able to, it will monitor and it will control the dosing levels depending on load, temperature, and everything else of the exhaust as well. So they are closed loop systems. Just to give you a little idea, this is some recent ones we put in. This was on new systems. So we've upgraded the infrastructure of a Southwest Police HQ, and this was two 800 kVA generators. And as you can see, just on top of those two containers, they're identical with 800 kVA generators. You have the silencer unit going into the SCR unit, and then it's discharged as well. And probably the better example of that is the next one. This was a 1500 kVA unit. Two of these were supplied to a distribution center. So these guys, as with the last application as well, wanted to participate in demand side response or balancing services, whatever you want to call it. Was pretty sure of that as well. So that gives you an idea. That's a 1500 kVA generator with an SCR on the end of it as well. So we've actually built a skid frame for the SCR and the silencer on top to be able to meet the noise requirements of the site, but also to allow for the abatement to be installed as well. So look, anything's possible, I suppose, but it's just the easier we can make it, the better, really. But that's on a new installation and on containers. We are currently involved with a few projects where we're doing refurbs, retrofits of these units into existing plant rooms. Sometimes they go on the roof of the plant room, sometimes they go inside. It's basically finding the exact space, but all that parameter is keeping the back pressure reduced to a minimum, and also getting that SCR as close to the end of the generator as possible to ensure the integrity of it working. So moving on a little bit to the regulation of the medium combustion plant directive. So the EA is the competent authority. So what happened was, back during the consultation period, DEFRA passed responsibility over the regulation of this to the Environmental Agency. The Environmental Agency are running a paper system at the moment, but will eventually run a computer system which will run this system and run the permit system. And I suppose the biggest thing to take from this today is that it's the operator's responsibility to ensure that whether it's a standby generator or generator running for commercial gain, it is correctly permitted. So there's a couple of types of permits, which I'll want to say standard and bespoke permits. But basically, the registration of these units was required within about 4 months of 2019 if it was classed as a brand new and there was no transitional rights of these units. So at the moment, I think there was a backlog when the legislation first came out from the EA, but I think, well, hopefully now they may have got to the bottom of that. You need to apply to the EA. There's plenty of information online with that. They'll talk you through the system. There's also consultants available who will take you through the permitting process. We've worked with a few consultants ourselves. By all means, give me a call if you want some help on this. We can have a conversation on this as well. And I suppose the biggest thing is one needs to be recorded, and this information needs to be retained for 6 years. So whether you're a standby generator or whether you're running it for commercial gain, you will need to keep records of this, of your operation of the generator. Also, there's some, if you change the generator, if you upgrade it to a new one, or if you upgrade it and it's more than 50% of its value, then it changes its operation. It's almost classed as being new. So there are some little things that need to be picked up on the guidance document. You have to be careful, and you may bring it out of the transitional rights you have into being a tranche, well, from a tranche A to a tranche B. So just be a little bit careful with this, because the legislation has probably clamped down a little bit over the last couple of years on older equipment being made into new equipment effectively, and also being refurbed. And one of the last things to look at, we mentioned the London emissions zone earlier on with the non-road mobile machinery directive. But one of the things I would say, there's air quality management areas, I think in Birmingham, Bristol is one as well, I think. So a lot of areas in cities now are looking to reduce emissions. So whatever the local request is for NOx levels, then that's where you have to abide by. The MCPD is almost the maximum level you have to come by, you have to abide by. So just a little bit, just be careful, and it's up to you as the operator to be able to talk to the local councils or the local planning people or the local EA people to understand where these air quality management areas are as well. So environmental permits, it's a legal document to operate the facility. I think anybody running large industrial type applications, whether biomass boilers, will be familiar with permitting. When you run in a generator, I don't think it's a common thing to do, and it's never been needed before. So I think the standard rules permit is something that can be done online. As I said earlier on, I think it's a computer system now. It can be done through the EA website. There's consultants who will help you through this. It's supposed to be quite a quick process. It's supposed to be within a month or two it comes through. don't know where we are with that at the moment and how quick that process is, but just be very careful with a bespoke permit if you have CHPs, generators, and quite a few other things on site. I think what you'll find is you may end up doing the bespoke route. This has a little bit more of a cost impact, but also has more of a time impact as well. A couple of years ago, people were talking that it's about 18 months to get one of these approved. I would hope by now that that's come down a little bit, but it's worth planning it as quick as you can for the permitting to make sure that you have these permits in place. So what type of permit do you need, but also what's going to be looked at? What kind of things you're going to have to look at? So you're going to have to generate the capacity in megawatts thermal. So if you're running quite close to 20 megawatts on a site, and you could be crossing over to the 50 megawatt from 50 megawatt thermal across by the efficiency, then you may end up falling in the industrial emissions directive. And there is some talk that some people have got close to this, and therefore you've been asked to go back and have a look at the efficiency of the engines to make sure that you do sit below 50 megawatts thermal with efficiency. So that's something just to note, particularly on large sites as well. I think also on hospitals, if you have multiple sites under the same trust within a few miles of each other, then I think you may be classed as one, and therefore you can probably creep over the 50 megawatt thermal. So just be a little bit conscious of that. Again, that's conversations with possibly environmental consultancies, or also with the EA, and again, their take on that as well. Also, you have to look at sensitive receptors around there, schools, playgrounds, areas of parks and stuff like that, which are classed as those as well. You need to look at what you're doing in a sense, is it static or is it mobile? Obviously today would be more static because it's for NHS. What fuel type? Are you running normal fuel, or we run our fleet on a biofuel, which reduces NOx and carbon as part of our greener activities. But you have to note what fuel you're running on as well. And probably one of the things you have to note the operating hours to make sure that you're below this 50 hours testing, and you actually comply with this and you meet with that. So under the permits, you actually will have to look at, and probably the maintenance records would have to be a little bit more stringent, and things being logged in different environments as well. So really that's about it for me today, but I'll just run you through a couple of conclusions. I suppose the first one is this legislation came into force back in 2019. And it really shouldn't have a major impact for anybody running a standby generator, possibly a permitting system, or logging them and make sure they're as well. Customer awareness is critical, and that's got better over the last couple of years, but there's still a lot of people who don't understand and are not at the level of awareness they are. Mainly a lot of that has been around triad avoidance, and whether you can do that outside of the MCBD or not, but I think that's fairly clear now. You will get captured by it, any sort of commercial gain. Anybody participating in balancing services of demand-side response, then it is going to have an impact, and you need to look at abatement. But I know some of the aggregators have put financial models in place where payback can be done in 18 months, 2 years, 3 years, depending on the level of work that's done. So these guys will work with you. So as I said, talk to your aggregators, have a conversation with them as well. There's still some confusion around MCBD, even though we're probably 3 years down the line from when the consultation happened. I think the EA is getting its head around it as well, and and it's run by one particular gentleman within the EA, and I think he's been fairly proactive. Current solutions are focused on after treatment. I think there's ways of reducing emissions by using fuels, as I mentioned, renewable fuels as well. The timescales have been short and are short, so 2019 has been and gone. 2025 will be the year before we know it, and 2030 will come as well. And probably the last point from this, more than anything else, is the legislation's only going to get it's only going to get more stringent. It's probably going to tackle particulate matter. Carbon dioxide is going to be one that's going to be looked at later on. It's going to come up to CHPs. It'll become more and more. So emissions legislation will become more and more over the next couple of years. So particular matter, I think, will be the next one will be attacked, and CO then afterwards as well. So yeah, so it isn't going to change. If anything, things are going to become more stringent, basically, with that as well. I suppose really the only thing for me to say now is if you need anything or we can help in any way, I've left my contact details on the end of this presentation. Please give me a shout directly. We can have a conversation. I'm more than appreciate it. But again, well, thank you very much for listening. Thanks again. Cheers. Bye.
Thank you very much for your presentation, Lee. So as Lee said, if you've got any questions, please direct them to Lee. You can see his contact details there on the final slide. Also a reminder to go to the Healthcare Estates website for information on other webinars we're running and that we have run, and for information on IHEAM Digital Week. But in the meantime, thank you again, Lee, for your presentation, and thank you to you for watching.